Okay, in this short video I'm going to show you some of my favourite conduction demos, conduction of heat. Here we have here, it's a metal rod. I think that's made of aluminium, which as we know is a metal, and metals are very good conductors of both heat and electricity. But we're after conduction of heat here, right? Heat's going to be produced by the flame of a Bunsen burner, and I'm going to heat this end. And the heat, because we've got a temperature difference, because this end will be hot, this end will be room temperature, heat energy will flow down the metal rod. Now, the method, the mechanism it's going to use is conduction, heat conduction. Right? Now, we can't see the atoms vibrating in the rod, okay, but we can see the effect of conduction down the rod. Now, that's what we're going to use, Vaseline, which is a type of sticky petroleum jelly, I think it's called, this was the true name. Now, what I've got here is drawing pins, which I'm going to stick temporarily to the end of the rod. Now, the reason I'm using Vaseline is because Vaseline is it's kind of a liquid. It's quite sticky and viscous at room temperature, but when it heats up it becomes very viscous. It will turn to a liquid and the drawing pins will drop. Okay, so it's only really sticky and gloopy when it's at room temperature. If we let it heat and warm up, because as the heat energy travels down the rod, it's going to obviously heat up the Vaseline and melt it. Right, so that'll do for now. We'll see how quickly. This is quite a neat little demo because it shows us how quickly conduction happens through solids. Okay. Right, obviously we want to heat it on a blue flame. Blue flames are much hotter than the orange flames. So if I position like that. Now, how does conduction happen in solids? Well, as this end of the rod heats up, the atoms in the metal rod are going to start vibrating like crazy. Okay? Now, because the atoms in solids are very tightly packed, okay? They're very tightly packed, they're very tightly bonded to each other, but when they start vibrating at this end, they're going to jiggle the ones next to them. So these start vibrating. Now, because they're vibrating like crazy, they will knock the atoms further along, and they will get these ones vibrating like crazy. When these ones start vibrating like crazy, they will pass the energy on, again by bouncing into them. Okay, because the atoms are so tightly packed, okay, because they're so tightly packed, the vibrations can very easily be passed on to the next ones, okay? But it's quite a slow process, as we see here, okay? Quite a slow process. If we maybe move it to the hotter part of the flame, just starting to go. Okay. Right, now I'm going to leave that going and show you a couple more. Right, as we can see, the right hand end of the rod is starting to glow. Okay. But it's taking its time. Now this is metal, I think, like I said, I think it's aluminium. There are better conductors of heat, which I'm going to show in this second demonstration. Here's a piece of kit that has a steel rod, a brass rod, an aluminium rod and a copper rod. Okay, now the way we can see the conduction is these windows here. These are called I think it's a type of photochromic material. When these get hot, when these black square rectangles get hot, they will turn white. Now the heat is going to be from some boiling water. Okay. Right, so we'll leave that one going for now. So let's put the boiling water there. And let's see. If we dip them in, we should be able to see the heat travel up these four rods. Right, which metal do we know is a very good conductor of electricity? Right, you'd be right if you thought copper. Well, for the same reason, it's going to be the best conductor of heat. And that should be shown quite nicely here. So if we pop that in, just pop the ends in. Okay, and if we leave that, we can see that the windows start to change colour. Okay. Right, which one? It's the copper, which is fastest, isn't it? Because these are changing colour all the way up to the top, so the heat energy is passed all the way along to the top. Aluminium, second. Okay. Brass, third, but in last place we can see steel. Okay, hopefully there you can see that the steel is a rubbish conductor of heat. Okay, there you have it there. Okay, so the steel only made it up to here. Copper made it all the way to the end. Right, now the fact that this piece of kit shows that steel is the poorest conductor of heat makes me think that this rod is actually a rod of steel. Okay, and as we know, as we can see rather, the conduction is happening quite slowly down the steel rod. Okay, but it's definitely moving in this direction. Right, but my favourite conduction demo is with this special piece of kit here. Okay, it's just literally a rod. One half is wood, and one half is a metal called brass. Now, what do you know about wood? What do you know about wood in terms of conducting heat energy? Number 3 is just dropped there. Okay, I think that's got to be next, hasn't it? Right, wood is what's known as an insulator. So all metals are good conductors of heat. As we saw here, some metals are much better than others. But wood is a very poor conductor of heat because it is something called an insulator. Right, this is my favourite. What I'm going to do, sheet of paper, I'm going to wrap the rod with a sheet of paper. So the boundary was here, wood, brass. Now if I sellotape that down, like that, okay, got a nice little jacket on the rod. Right, okay, we're going to call it a day with that demonstration there. Right, now what I'm going to do, I'm going to slowly singe the outside of the paper with the flame. Okay, so let me just move that slightly back. Okay, in the middle of the shot. Right, let's see. Now I'm just going to gently bring that through the flame. I'm not going to stick it in and hold it in and set the paper on fire. I'm just going to gently stroke the flame because something very, very interesting happens in the middle of the paper. So you see it just starting to. just starting to go there. It's all the way around. Okay. Right, what do we notice there? Okay, as we can see, the paper on the wood side burned, but the paper on the brass side, on the metal side, completely untouched. Not untouched, but unburned. Okay? Right, what's the reason for that? Well, it's all to do with conduction. It's all to do with the fact that this brass is a much better conductor than the wood. Now that, I can feel that feels quite hot on that end, but the wood does not feel hot at all. Now the reason it's burned, the reason the paper's burned is because the heat energy goes into the paper and it has nowhere else to go. Because wood is such a good insulator, it's such a poor conductor, the heat is trapped in the paper and it makes it burn. However, on this side, the heat goes into the paper and then straight into the brass and moves down the metal rod. And that happens so quickly that this side doesn't burn. Right, there you have it. My 3 favourite conduction demonstrations.